These notes are going to be about geometric series, and geometric will be a little bit different from arithmetic because with arithmetic we only looked at finite series, and that's because if we have a common difference that's positive, then your numbers are going to be getting bigger and bigger and bigger, and if you added them together the sum would eventually get to infinity, and that's not a number we can like conceptualize. And if the d value is negative, then eventually we would be adding huge negative numbers and we go to negative infinity. So talking about the infinite sum for an arithmetic series is kind of boring. But with geometric we can talk about finite and infinite. So first we're going to talk about finite. And the sum for a finite geometric series is s sub n equals a sub 1 times, and you could write a little dot there, you could put it in parentheses. I've seen it both ways. Both are fine. So there's our formula. And so I'm just going to go quickly through some simple examples since you guys have done this before. So the instructions will say to find the sum. Let's say the first example is that we're doing 16, negative 8, 4, negative 2, 1, and n equals 18. So I need to know what my first term is. I need to know what my r value is. So the pattern for this is that it is dividing by 2, dividing by negative 2. So I'm going to say that the common ratio, or the number that we're multiplying by, is negative 1/2. And then I already know that n is 18. So I have enough information to find the sum now. So I'm going to say 16 multiplied by 1 minus, and anytime you have an r value that's negative, you have to put it in parentheses before you raise it to an exponent. And anytime you have an r value that is a fraction, you also have to put it in parentheses before you raise it to an exponent. So up here it mattered that it was in parentheses, down here it did not matter because I'm not raising it to an exponent. So that's just something to keep in mind. Now, these can be kind of tricky to plug in, so if you have a newer calculator, hitting the alpha y equals button and using fractions to plug this in is really good, just because then you are less likely to plug in something wrong. So 1 minus negative 1/2 to the 18th over 1 minus negative 1/2. I guess I should have put the times in there. If you do not have one of these calculators, or a calculator with this like update on it, then you'll need to be really, really careful with your parentheses to make sure you plug it in correctly, and I can help you during class on that. We know that eventually the reason this is such a nasty sum is that eventually we would have just been adding fraction after fraction after fraction. So I don't want you guys to ever round these decimal answers. I want you to write the answer in fraction form so that it's exact and not approximate, because we can always write the exact answer for these. They will always be rational. So, well, I guess unless we had a pattern that was like multiplying by pi or something. Alright, so there's the sum of the first 18 terms. Let's look at one that starts off in summation notation. So I'm going to say I is 1 to 8, and negative 4i is the pattern. So first I need to know what the first term is, what the r is, and how many terms I'm finding. So, not negative 4i, negative 4 to the I, sorry about that. So the first term is what I would get in if I plug in 1. And so negative 4 to the first power is just negative 4. The r value here, a lot of students will think that the r value is negative 4. That would only be the case if there were parentheses around this. Remember, anytime you have a negative as the base of an exponent, it has to be in parentheses. So that means that only the 4 is the r in this problem. And then the number of terms we're finding is 8. So first 8 terms would be -4 multiplied by 1 minus 4 to the 8 over 1 minus 4. You'll notice that since my r value is positive this time, I'm not worried about putting it in parentheses. So 1 minus 4 to the 8 over 1 minus 4. And so the sum of the first 8 terms is negative 87,380. Okay, next, for an example, we're going to determine the number of terms in a series. And just like arithmetic, I believe this is probably the first time you guys have seen this. So they could give you the information as like some terms written out, or they could just tell you the first term is this, and the common ratio is this, and here's the sum. So I'm just going to go ahead and give you guys the information this way, but there's a variety of ways they could introduce the information to you. So I'm going to keep in mind, I think I just ran out of lead. I'm going to keep in mind that my formula is S sub n equals the first term times 1 minus r to the n over 1 minus r. And then I'm going to go ahead and plug in all the information I have. So I know that the sum is 2,735. I know that this is going to equal 5 times 1 minus negative 3 to the n over 1 minus negative 3. So that's all the stuff that I know as of right now. So what I'm going to go ahead and do first, because this, again, just like with the arithmetic series, it's just simplifying for a while until we can get it down to a form that we know how to solve. So for me to get rid of that 5 in the front, I'm going to go ahead and divide by 5 on both sides. So 2735 divided by 5 is 547. So on the top, I've got that. On the bottom, I have 4. So then I'll go ahead and multiply by 4 on each side. I can go ahead and subtract 1 over. Oh, getting ahead of myself. So I subtracted the 1. And then I can divide by a negative. Now, if you guys recall, typically when we solve for an exponent that's a variable, we convert the exponential form into log form. And then we can plug it into our calculator. So this would be log base negative 3 of negative 2,187 should equal n. The only problem with this is logs are not allowed to have negative bases, and you can't take the log of a negative, which means this is not possible to plug into our calculator. So what I usually do when I hit this stage is I just plug it in as a positive instead. So I'm going to plug in log base of positive 3,2187, and that's because if we think about mathematically what's happening here, we're just repeatedly multiplying negative 3, and it happens to be a negative answer, which means that I know that my n value is going to be odd, because if my exponent was even, then it would have gotten rid of that negative. So I know my n value is going to be odd. But if I plug the log in this way, all it's going to do is say how many times should I repeatedly multiply positive 3 to get positive. And so we should still be able to find the n value even though we're not plugging in the numbers for the actual problem. So it says that n is 7 here, and I can just go back and double check if I'm not trusting this since I didn't do the real math for the problem. And negative 3 to the 7th power really is negative 2,187. So that's a good way to solve it. We're just kind of faking it so we can actually use our calculators to help us on that. Okay, so that's about all we will do with finite geometric series. So now let's go ahead and look at infinite geometric series. So the sum, and you'll notice there's no sub number this time, and that's because we won't have one. It will just be a dot, dot, dot. It's going forever. Technically, I guess you could put a little infinity right there, but you don't need it. We can just put an S. And this only works if the absolute value of r is less than 1. So it can be a positive r or a negative r. It just has to be some fraction that is less than 1. Okay, so here we're going to say if the absolute value of r is less than 1, then the series converges to a specific sum. So that means that the sum of the series is approaching a certain number. It's kind of like the idea of a limit. It will never exactly get there, but it will get very stinking close. All right? So converges to a specific sum. So if you're looking at a sequence, sorry, not a sequence, a series. If you're looking at a series and the r value is less than 1, then you can say, yep, it's going to converge, and there's going to be some specific value for the sum that we'll be able to find. If r is greater than 1, then the series diverges. And the way that I remember this now that I'm teaching it, which is kind of silly because I obviously didn't learn it this way because the books have come out recently, but like the Divergent series, the divergent characters in the series are the ones that like don't fit into a specific bracket. They kind of like go off, and so that's how I remember it, is like these go off to infinity or negative infinity or whatever. It's just adding a lot of numbers that wouldn't get anywhere, and then converging is like you're converging to the norm or something. Anyway, that's how I remember it. So we in high school don't talk a lot about divergent series. That's something that in college they get a lot deeper into, maybe even in AP Calc actually. So for us, we'll say it diverges, and then we'll kind of ignore it after that, but converges we're interested in because we can use the formula. So, for the examples that we're going to do here, first we're going to determine if the series converges or diverges, and then if it does converge, we want to find what it converges to, which is another way of saying the infinite sum. So, for the first one, and I said all that so I wouldn't have to write it, so if you want to pause and write that those are the instructions, then you could do that, but you don't have to. So 2/3 plus 1 plus 3/2 plus 9/4 plus dot dot dot. So this dot 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 is telling us that this pattern is going on forever, so that means this is an infinite series. And when I look at this, the very first thing I want to see when I am dealing with an infinite series is what the r value is. So this part right here doesn't necessarily show me a lot. In my opinion, I like looking at this. So I can see the top is multiplying by 3 and the bottom is multiplying by 2. And if I look back at the beginning, that pattern would hold true. So that means that my r value is 3/2. And my r value is greater than 1. It's a fraction, which usually tells you that we can converge, or it feels like they usually do. But in this case, it doesn't because it's too big. So here we would say that the series diverges, and we're done. For this one, I'll go ahead and give it to you in the sigma notation, or the summation notation. So if you look at this one, I can see that my r value here, because that's always the first thing we look for, I can see the r value here is 4/7. And I know when you're looking at this, you're like, what? That exponent is k plus 1? That can't be true because we've never had a k plus 1. But this is still a geometric series because the pattern is still that it's multiplying by a fraction. So I'm just being tricky here. I just wanted you guys to recognize it truly is still a geometric series. So here our r value is 4/7, which means we really can find the sum. So I'm going to say this converges. And then we'll go ahead and find the sum so we know what it converges to. So the first term, I have to plug in 1 to get it. This is not one where it's like, yeah, I know what my formula looks like, so I can automatically tell what the first term is. and I'm not going to round a decimal this early in a problem. So negative 48/49 is the first term, divided by 1 minus r. And again, if I was you and I had the updated version of the operating system for my calculator, I would probably use the fraction button. If not, you're going to want to be really careful about parentheses when you plug this in. And then again, we're going to turn these into fractions so that we can have more accurate answers. So the infinite sum for this series is negative 16/7, and so we would say that's the number that it's converging to. Okay, next we're going to look at a problem where the instructions are to find the common ratio of the infinite geometric series. So for finite series, we looked at, oh, if this is the sum, how many terms do you have? And in the case of an infinite geometric series, that would be silly because you have infinite terms. So for us, when we look at solving for an unknown, where if we have, if we have been given the sum, then either we would be looking for the first term or we're looking for the common ratio, because those are the only two other variables in the formula. And so typically they'll be like, oh, solve for r. So that's what we're doing here. So they're going to tell us that the first term is 3, and that the infinite sum here is 27/7. So I'm just going to keep the formula in mind, and then I'm going to replace everything that I know. So I've got S is 27/7, the first term is 3, and this is 1 minus r. So since I have a fraction equals a fraction, I'm going to go ahead and cross multiply. So I've got 27 times 1 minus r equals 21. And you have different ways you can get rid of this. I'm going to go ahead and just divide by 27. If you wanted to distribute, you are more than welcome. You'd still get the right answer. And then I'm going to go ahead and subtract 1 to the other side. And so that leaves me with negative r is negative 2/9. And so that means that the common ratio must have been positive 2/9.